Well, a very good morning. Thank you so much for joining Goma School's live coverage mathematics, quadratic equations and expressions as well. And in this case, we're going to solve the simultaneous equation using the graphical methods. Remember, the simultaneous equation can be calculated using the elimination method and as well the substitution method. Those are the areas or rather the formulas we used in calculation of the simultaneous equation. Meanwhile, on the quadratic equations and expressions, we can use the graphical method and solve these given simultaneous equations, as I'm going to illustrate on this board live here. And we have a question here: use a graphical method to solve the simultaneous equations. And the two equations we are given, we have y is equal to 2x squared minus 3x minus 6. Another equation is y is equal to x plus 4. That is what we have, and you're told to use the graphical methods to solve that equations. When you're given a question in mathematics and you're being taught to solve, then it means you have to find the values of the known. So at the end of the day, what we need to calculate is the values of the f, because you're told x is equals to these values here, 2x squared minus 3x minus 6. So to solve, we need to find the values of the known. In that case, you're getting the values of the x. So we have the two simultaneous equation there. So what we usually do, we have to come up with the table of tabulation of these values here. We make the tables for these two equations. Then from there now we graph our curves. So let's get to it. The first equation there, what we do, we have to come with the table of values. So in this case, because you're drawing the curves, you are advised to use both the negative values according to the Cartesian plane. Let me illustrate them here briefly. When you have a Cartesian plane given this form here, we have the values. This is y-axis. This is x-axis. So in this case, this is 0. So we have the values in the x-axis, which are negative points. So from 0, we have -1, we have -2, we have -3, all the way the numbers proceed this left side. From 0 to the right side, remember these are positive numbers. So we have 1, we have 2, we have 3, we have 4, the number proceeds. From this one, 0 upward, these are positive numbers, +1, +2, 2, 3, 4, the number is, and consequently it happens in this case here. We have the values which are negative. So this is just a brief sketch of a Cartesian plane. So when you graphing the values of your graph, then the table of tabulation, you have to include the values of the negatives and as well the positive values, because at the end of the day, because you're going to come up with the curve, then it has to appear, it has to cut in both sides of the Cartesian plane, either to appear this way or the way it is going to appear. But we have to get the values which are in the negative side and as well the values which are in the positive side, which is not necessary, but when you get in the table of tabulation, it is useful to include that. So what you're going to do, guys, I'm going to get the table of tabulation of these values here, and this is how we can come up with. All right, let me have it here. We have the values of x and the values of y. So the values of x, students, it is upon you to decide the scale you're going to use, because this applies the knowledge of the scale, because you don't need to have a bigger the graph or rather a smaller one, which maybe you will not be able to read. So you have to get a suitable scale whereby the graph has to fit 3/4 of your graph book, which you have been using. Then from there now you can feed the values and then you plot the points which are given. So many times the range or rather the interval of the x-axis values, they are usually given whereby you're going to be told the values of x between this range to this range. Many times the examiners are giving these values, but many times the values are not given. So it is upon new students to come up with these values. So to come up with these suitable values, you don't need to exceed, because the graph don't need to be so much bigger. So we can assume to start with -2, we go to -1, we go to 0, we have 1, we have 2, we have 3, we have 4. So these are the values which we just have them from the mind, because at the end of the day we just need to plot the values. The way whoever uses bigger number than this one, we're going to get the same curve in our graph book. But what I said, we just need to use a suitable scale which is going to give us a smaller or rather a suitable graph which fits our graph books. So with that, Now we have to use our calculator. Then we compute when x is negative 2, what will be the value of the correspondent of x. So pick your calculators. Let's feed these values together. So negative 2, when x is negative 2, what will be what? So we are going to plot this curve here. So the first thing we're going to do, we're going to have our Cartesian plane here. This is the graph we are going to use to solve our the problem we have on board. So let's come up with the Cartesian plane. Right, that's our Cartesian plane. So we have the x-axis, then we have y-axis. So we have 0. So we have to come with the scale, suitable scale. So I said this one, you can use this one. So it will be negative 2, then we have negative 1, 0, then we have 1, we have 2, we have 3, we have 4, etc. So that one we can use as the values in the x-axis. For the y-axis is not how we are going to work out with the calculators. You see this problem there, then you are going to feed them there. So let's come up with our graph. Right? So when x is negative 2, what you do, you come to this equation you've given here, students. These are equation, the reference of the equation. So y is equals to everything here. Now we are going to substitute the value of x with every entry in this table of distribution there. So y is equals to 2x squared. X squared is negative 2. So that is 2 in brackets. 2 in brackets, it is negative 2. Close the brackets, squared minus 3, close the brackets, x, which is negative 2, close the brackets, minus 6. So answer you're going to get, it will be positive 8. This is positive 8. When x is negative 1, you can compute that later. Y is equals to 2x squared. 2x squared minus 3x minus 6. And you're going to get the answer being negative 1. The answer is negative 1. When x is 0, then it will mean you are going to work with only this value here, because n number, when multiplied with 0, it is 0, then the value there will going to be negative 6. Negative 6. When x is negative positive 1, y will be what? So it is 2 in brackets 1, close the bracket, squared minus 3x minus 6. And you're going to get the answer being negative 7. Negative 7. When x is 2, that is 2 in brackets 2 squared minus 3 in brackets 2, close the brackets, minus 6. Get negative 4. Negative 4. When x is 3, computing the calculator there, 2 in brackets 3 squared minus 3x minus 6. The answer will get to be positive 3. Then finally, when x is 4, there will be 2 in brackets 4, close the bracket, squared minus 3 in brackets 4, close bracket, minus 6. That's we're going to get 14. So these are the values of x we have, students. So what we do, we come, the highest number, it is 14. The smallest number is negative 7. So you come in your Cartesian plane and you come up with a suitable scale. So this is how we do it. We can use a scale of 2. So this will be 2, that will be 4, that will be 6, 8, 10, 12, then we have 14. Consequent happens here, negative 2, negative 4, negative 6, negative 8, negative 10, for example. Well, with this table of the values here now, let's proceed in having our curve. So when x is -2, y is 8. So we come here, these are the values of x. When it's -2, the value of y is 8, which is positive. So x and 8, they intersect somewhere there. So that's the value of. The second point is -1. When x is -1, y is -1. So -1, -1, it will be somewhere there. You can have a star there. Then when it's 0, it is -6. At the 0, -6, we have a star there. At 1, when x is 1, y is -7. -7, it will be there. When x is 2, value of y is -4. So x, 2, 4, that is there. Then we have when x is 3, the value of y is 3. 3 and 3, somewhere there. Then finally we have when value of x is 4, then the value of y is 14. 4 and 14, somewhere there. So what we usually do now, you have to use your free hand and you come up with that smooth curve. So this is how we do it. So we started from this point here. So this is how it goes. Right. Pass through those dots that way, then the curve should be smooth. Then from there it goes up. It goes up all the way the final one. That case. And then when you have a curve, you are advised to name your curve. So this curve, our curve here, it is y is equals to 2, this one here, 2x squared minus 3x minus 6. So that is our curve, the first curve. Remember, this is what we are using to solve the simultaneous equation which were given, which are here. So we made the first table. Then we are solving these two equations, the simultaneous equation. We have this one and this one here. So we have y is equal to x plus 4. When you have one unknown and a value, definitely that equation, when you plot it, it becomes a straight line. So to plot this one as well, we have to come with the table of tabulation of numbers. So what we do, let's have the values of x and the values of y. In this case, just have two values, which is -2 and a +2. So when x is -2, I will solve with this one. When x is -2, y will be what? So you substitute. So when y is -2, that will be -2 plus 4, which will be +2. When x is 2, substitute here. When x is 2, then y will be 6. Then you can come in the same graph, then you plot these values. When x is -2, y is 2. When x is -2, y is 2. Here you have a point there. Then when x is 2, y is 6. When x is 2, y is 6. Is somewhere there. So what you do, you join those 2 points to form a straight line. In that case, ours might not be much exact because you're not using the graphical boards, but I have to illustrate you and show you the correct values. So we have to draw a line that way. So this now you have to name it. This is y is equals to x plus 4. So you have to solve these two simultaneous equations, this equation and this equation as they are given here. Use graphical method to solve the simultaneous equation, these two equations there. So what you usually do to get the calculation of this one is that the solution of those two simultaneous equation is at the point of intersection of the curve and the straight line, right? Where the straight line cuts the curve, that is the solution of our simultaneous equation. In other words, those will be the values of x. So we might find that many times the values of the x are either negative or positive. So in this case, you're going to read off this point here, because that's the point of intersection on the positive side. You read off the values there. Again, it has cut the curve in this negative side of the Cartesian plane at that point there. Then you read all the values there. When you work out that one, the values of x are given as, because I'm using the board, the plain board, maybe I may not be able to get the exact points for those who are using the graph, but if you're using the graph by students, you're going to get the value of x of intersection For the positive side, you're going to get it is 3.5, which is exactly what we have, 3.5. That is the value of x in this case for the positive side. For this one, it is negative 1.5. Negative 1.5. So x is equal to negative 1.5 or 3.5. That is the solution of these two simultaneous equations. So that's how we usually do it, students. Let's get to part B. By drawing a suitable straight lines, use this graph of y minus 2x squared minus 3x minus 6 above this one now, which is here, students. This is what we have to solve the following equations. The following equation we have, the first equation, which is 2x squared minus 3x minus 6 equals to 0. Then Roman 2, 2x squared minus x minus 8 is equal to 0. Students, when you're given such equations and you to use a graph as a reference to find its unknown, what you usually do, you get the equation of the curve, then you minus the equation in question which you want to calculate. So this, the first equation you need to solve using our equation of the curve we have there. So to get the solution of this one, what you do, let's place some more space here. You get this equation, which is y is equal to 2x squared minus 3x minus 6. This is the equation we need to use to solve this equation here. Not simultaneous equation for this case. Let's start with the first one. 2x squared minus 3x minus 6 is equal to 0. So what you do, you get this equation and then you rearrange it in the form of y is equals to mx plus c, the linear equations. So you arrange it here. So this equation here, 0, it will be there. Then this will be 2x squared minus 3x minus 6. So you minus. So this equation, when you minus, you're going to get y is equal to 0. But everything here will cancel. So y is equal to 0. Students, we know in the Cartesian plane, the line y is equal to 0 is the x-axis. X-axis. Don't forget that. And when you told x is equal to 0, then in this case we means y-axis. Don't forget that. So our aim is y is equal to 0. That's what we have. So this is the solution. If we get this one, if it were another equation, then we can plot it in the same graph, and the point of intersection with the line you're going to get with the curve you're going to have, that should be the solution of the values of the x. But in this case, we find that y is equal to 0, which means the x-axis where it cuts the curve in question, that will be the solution of our equation. So we come to a graph there. This is the x-axis. It cuts the curve at that point, and it cuts our curve at that point there. And what are the solutions? For the negative side here, the x-axis cut the curve at point which is what? Negative 1.2. Negative 1.2. In the positive side, it cuts at 2.6. 2.6. So these are the solutions of this equation here. So we can say x, this case, is given as negative 1.2, or it is given as 2.6. That is the solution for the value of x in that case. Then finally, we have the final equation there. 2x squared minus x minus 8 is equal to 0. The same formula we're going to use. You're going to use the equation, the reference equation of our curve. We minus this equation, so we can plot it here. Then our equation was y is equals to 2x squared minus 3x minus 6. Now we minus this equation. 0 is equals to 2x squared minus x minus 8. You minus those two equations. In this case, we find y is equal to 2 minus 2x. Y is equals to 2. This is 2. This is 2. This will go. This is 2x. So this is 2x minus 2. So that's the table, the values we have. So it will mean this is not a straight line, which we can just say it is either x-axis or y-axis. So it will mean we have to come up with a table of tabulation and get the values of these, or which are going to give us a straight line. So we can have just the two values to get the values of x, the values of y, and these are to appear. You can have -2 and a +2. So in this case, when x is -2, what will be the value of y? So substitute 2 in brackets 2 minus 2, which is going to give you, when x is -2, so it is 2 multiplied by -2, which will be -4 multiplied by minus, which will be -6, +6. Is that okay? Then when x is 2, I'm getting the value of x being -2. -2. So these values you can plot on the graph. When x is -2, y is 6 positive. You have it right there. Then when x is 2, y is -2. -2 is here, somewhere there. Then you join these 2 points this way, this point and this point. Join them. Then you are advised to name this equation. It is y is equals to 2 minus 2, 2x. So the solution of this equation is the point of intersection of this straight line and the x. So in this case, the point of intersection of this line with the curve is here. So you read the values of x in that point. The line, it is here. It casts the curve at which point? There. You read this point. When you have that in your graph book, you're going to get the value of x is given as, in this point here, is -1.7. At this point, we say it is -1.7. In the positive side, we're getting it being 2.2. 2.2. So that is solution for this equation, that x is given as -1.7 or 2.2. So that's, students, how we usually handle the simultaneous equation using the graphical methods. You're going to do the more examples under this topic of quadratic expressions and equations, like 2 or more examples. Remember, you can get us on all social media platforms at Goma Schools, on Twitter, on Instagram, and you can have your questions and your feedback will be checked and will respond accordingly.